Hello, Kim. How are you?
Hi, I'm
How are you?
quite well. You? I'm quite
I'm
well, and
good.
how are you?
I'm good too. Are you here to attend maths?
Yes.
Oh, all right. Thank you. Thank you. Let's just wait for others then so that we can start for today's lesson.
Oh, okay, no problem.
Yes.
Negative. Okay. And then
Hi, Tabile. Welcome to today's lesson. How are you doing?
I'm good, and you?
Oh, I'm good too here. Okay. Oh, at least you are getting some numbers. Then let me wait for some. Maybe we can start at 5 past. Oh, hi guys. Now it's 5 past 8 on the clock on my watch this side. Can everyone hear me?
Yes, sir.
Okay. Kim, can you hear me? What about others? Can everyone hear me, guys? Tabile?
Yes, sir.
All right. Thank you. So, guys, I dropped something for you on the channel last week. You guys have some look on it. My friends are now quiet. Did you guys try to have some look on that work that I've dropped in the channel about the areas wisdom proportionality theorem? Oh,
Yes.
I see. Oh, how did it go? Was it okay?
There are some challenges that I had, but I think you'll correct me.
Oh, definitely, definitely. I would love to. Let me quickly share my screen and see what we can do for tonight. You will tell me if you can see my screen outside. Sharing. Can you see my screen outside?
Yes, sir.
Okay, I hear feedback from only Kim. Tabile, can you see my screen?
Yes, sir.
All right, thank you, guys. Let me then go to my textbook. My textbook is right here. So I've got that on the screen. I've sent that question, exercise 4. I sent number 1, 2, 3 from A. So how did you guys try this? What did you guys do there? Anna, who said he tried this one? I forgot. Is it you, Kim, who said that you've tried it?
So to be honest, I did not try the work.
Oh yeah, I love your honesty. So okay, guys, then let's just work this work out. Okay, can you see? Are you able to see everything here on the screen? Exercise 4.
Yes, sir. Yes, sir.
Okay, thank you, guys. I love hearing those feedbacks. Just please shout it out if maybe you are left behind, or you want some clarification, or you can't see, or you didn't hear something. Just shout it out. So exercise 4, they are saying in the sketch alongside, we are given that AF. There we can see AF is parallel to DE, okay? And then we are also given some information, the ratio AD is to DC as 2:5, okay? AD is to DC, you can see that. Okay, and BF is to FC, BF is to FC, is 2:3. Okay, then what are you going to do with that information? You just go to your diagram, you write that thing down, you're taking some notes. Where's my ball pen? Here is it. Okay, I don't mind using that black. Then they are saying AD. There is AD. We can say that is 2. Okay. Then that is 5. Okay. We have BF here. We have FC there. And BF is 2. This is 3. Okay. Now, do you guys agree now if I say to you, where can I write? Oh, let me use this space here. F E. F E over EC. EC is equal to AD, AD over DC. Do you guys agree to this statement that I've written there?
Yes, I understand.
Yes, sir.
Okay, what's the reason behind this statement? Anyone, guys, of you who can tell us the reason behind this statement? Why do I say BE over EC is equal to AD over DC?
So they are in, if you look at it as triangle A, so I can't see the triangle properly, but they're proportional because of the corner lines.
Sorry?
The proportional proved by the parallel line.
Oh, yes. So you are going to have your reasoning as Brock theorem. Brock theorem, then you state your parallel lines that AF is parallel to DE. Okay, yeah. So meaning for FE as well, we are going to have this ratio. This is FE. That portion is going to be 2. Okay, and again for EC, we will have 5 there. But then for these two here, actually, let me use different color for this one. Let me erase this one and give this a variable A, give that a variable A. And then now I come to this proportionality theorem that we have used there. And now I say FE here. This portion is going to be 2B. Okay. And then EC is going to be 5B. Okay. Do you guys agree to this?
Yes, yes.
Okay. Now let's go to the question and see what we can do. Number one. Number one is requiring us to calculate the area of triangle ABF. What is ABF? ABF is this triangle, okay? And ACF, ACF is this triangle. Anyone, guys, with some idea of how we can calculate the area of those triangles and then use their ratio to calculate what we are required to do?
Sorry, can you please repeat your question?
Okay, so the question is this one. Okay, let me remove this thing, this flag of mine. We have this question, number one from A, exercise 4, is requiring us to calculate the ratio area of triangle ABF over the area of triangle ACF.
Okay, so from the last time we did this, I remember one of the notes saying that the ratio of the triangle, or one of the triangles over the other triangle, is equal to the ratio of the proportion of the sides.
Okay, that one, yes, I agree, but conditionally. On what condition, maybe?
Okay, I can't answer that one. So
Sorry?
I can't answer that part.
Oh, okay, no, it's fine. We can quickly just go up there to remind ourselves. These are the conditions that we talked about. Where is the first condition? Oh, okay, up there. Here they are, these conditions. What I did ask you first, I asked you about, let's say we are given this triangle, we are given this right angle triangle with this horizontal line, maybe let's say it's B centimeters, then the vertical one, let's say it's maybe 8 centimeters, and then you are required to calculate the shaded area of this triangle. Then you guys said to me the area of this triangle is going to be half times base times height. The height of this triangle is going to be A. Do you guys agree to this information?
Yes, sir.
Yes,
Okay. Okay, thank you, guys. Now I said, let's do this. Okay, this triangle of mine, let me do this. This is my triangle. Okay, and then I shade again, I shade. Now it's no longer a right angle triangle. But now the point, okay, A, B, C. The point, the line BC is still B in this case, but now we still have that height that is perpendicular to the base here. And then this height is A. Now I say to you guys, the area of this green triangle here will be the same as that other one. Will be half times B times the perpendicular height of this triangle. So will still be at half times base times height, even though this triangle is not a right angle triangle. As long as you have that perpendicular height there, then you can use that. Does it make sense, guys?
Yes, sir.
Okay, thank you. Then the last one, I forgot, but there's someone who said that formula for area rule. Area rule whereby you are given a triangle. Let's say this is A, B, C. This triangle ABC with an angle there. Now here, they give you a side A, B, C there. So with this one, okay, I agree. You have maybe your base in this triangle, which is this one. Yes, this is the base. But you are not given the vertical height that is perpendicular to the base. You're not given that. So what are you given in this case? You are given that angle there. And then how are you going to calculate the area of this triangle? You are going to use the area rule, which says that the area of this triangle is going to equal to the half times one of the sides from there at the angle, which is now AC, and AC is B, okay, times the other side that meets that other one at the angle, which is this one, is A times A, times sine the angle there that we are having of focus is A. Therefore, if we are using the area rule, the area of this triangle will be half times B times A times sine angle A there. Does this make sense, guys? Does this part make sense to everyone, guys? Or
So
there's
could
someone?
you repeat a bit?
Oh, okay,
So
okay,
could you
okay,
please
no.
repeat? You broke up
Okay, no,
in
it's fine.
between.
Okay, let me repeat. Did you only get lost for this one, or should I also repeat even those ones that I've explained before this?
Yes, you can repeat.
Everything? Or
Not
you
everything.
were
You
only
can
lost
explain.
to this one? Sorry?
You can explain the area rule again.
Only area rule.
Yes, for me. The others can talk for themselves.
Okay, but they are quiet, eh? Are you guys fine with the first two conditions that
So
we had?
area rule only.
Sorry?
Area rule only, sir.
Oh, okay, fine. So the area rule is like this, guys. You will be given a triangle. This is area rule. This is area rule. Oh, area rule, guys, is also important. You can use it in analytical geometry. You can use it in trigonometry. They can ask this a lot, but they won't tell you that you need to use area rule. You as a mathematician, you will just have to think, okay, area rule is applicable here, looking at the information that you are given and what you are required to calculate. So this is what I'm saying. And you need to know what is the difference between the triangles so that you now can apply the area rule. Remember, I said with the first two triangles, let's say this is triangle 1, this is triangle 2, this is triangle 2, this is triangle 3. Okay. Now, this one triangle 2, let me first with triangle 2. When you look at triangle 2 there, it's a right angle triangle. Very, very simple triangle because of that 90 degrees. This one directly from seeing it, you can see that it has got the height there. Why? Because that line is perpendicular to this horizontal line, the base. That's why we are going to say the area for this triangle 2 is area is equal to half times base, which is this side, times height, which is the side perpendicular to the base. Okay, I hope it makes sense, but you guys will shout out if you didn't understand this triangle 2. Okay, but in fact, let me not wrap it. This is a perpendicularity of ours there. Now let's come to triangle 3. We are given triangle 3A, B, C. The information that you are given there, you are given a side BC here as A. You are given the side AC as B. You are given the side AB as C here. And then in this triangle 3, you are also given the perpendicular height. The height, I don't know how I can define the height, but I believe everyone has got the picture of what the height is. But this height is perpendicular to the base. This is the height of this triangle. This height is perpendicular to the base, because yes, the height that we are going to use needs to always be perpendicular to the base, so that we can use the formula. Let's say this height is h, same area for this triangle will be the same as the area for that triangle. Area is equal to half times the base of this triangle at this point is A, okay, times the height for it, the perpendicular line that is perpendicular to the base is h. This point, this is the formula for triangle 3. Okay, let me erase this. Now let's go to triangle 1. So triangle 1, let's say it's R. I didn't want to erase that. Let's say you have got A, B, C. Okay, and then this is the side A, this is the side B, that is the side C. Okay, now I want you guys to hear me with this part. Only if in this triangle 1, you are given the perpendicular height, if you have this perpendicular height h, you can use the formula A is equal to half, what is the base of triangle 1 is A, times the height of it is h. Only if you are given that a perpendicular height. Okay, now let's say you are not given that perpendicular height. Now this triangle becomes different from these other triangles. Now it doesn't have the height. You are only given the side A, B, and C. And then you are also given the angle there, this angle. Let's say it's angle beta or whatever it is. Maybe let's say this is theta. Okay, this is theta. Hey, my theta is poor. Okay, but it doesn't matter. Now the area of this triangle, it doesn't have height. Maybe someone can be shocked, or oh man, the formula I know for the triangle is half times base times height. This one, that's where area rule applies. Area rule that doesn't involve height at all. It only involves that angle there. And note that where the angle is, now the angle is there at A. So the only sides that you are going to use are the only sides that meets there at the angle. You will leave this side out. You're going to use this side, those sides that meets there at the angle. Then you say your area is equal to half times that side there is C, okay, times this side there is B, times sine angle there is theta. Does it now make sense, guys?
Yes, sir, it makes sense.
Okay, Does it make sense to everyone, guys? Just don't be shy if maybe you didn't understand. I can repeat it. Does it make sense to everyone, guys?
Yes, sir.
Oh, okay. Thank you, guys. Then let's just move to those conditions that you're having. We have this area ratios. In this section, you will learn how to calculate. Oh, doesn't matter. Type 1, same perpendicular height. This one. When you look at the triangle APB, let me maybe use the color. APB is oh, that's poor. Okay, yeah, not bad. Oh no, this is poor. Let me just say we have APB here. Let me just separate it. This is our APB, and then our PC, like this, PCA. Okay, A is there as a common angle or a common point. Then we have C here. We've got P here as well. We have B here. And then now we have the line there from A, and A is common on both triangles. And then we have the perpendicular height to both bases of the triangle. So anyone, guys, of you who maybe can tell us what is the area of, how can I hide it? No, this is going to cause some mess. Yeah, it doesn't matter. Anyone, guys, who can tell us how to calculate maybe the area of triangle APB? I want to hide that. Okay. Is there anyone, guys, who want to give that a try?
So can you please repeat what are you trying to prove?
Oh, okay. I was saying I have these triangles here. Let me do this. I have these triangles here. Actually, let me just show this triangle. Anyone who can tell us maybe how he or she can calculate the area of the triangle APB?
So you can use the base PB and the perpendicular height given for the triangle ABC.
Oh,
This is
yes,
part of
yes,
the
yes, that's
formula.
correct. Same applies with APC. You can use the formula base times height, because we have got that perpendicular height. It's perpendicular to the base. Yes, that's correct, sir. So now let's go to this part here. They are saying this one here. Eraser, and then I want us to look at this. Okay, that's the area of ABP, which is this triangle, this one. Okay, over triangle ACP. ACP is this one. Oh, let me use the different color. Where is my color? Let's say okay, this one. So as you said, that the area of triangle APB will be half times its base, which is BP, times the height, which is the perpendicular height to the base H, all over. Now the area of ACP, which is the blue triangle in this drawing, is going to be the half times the base PC times the perpendicular height H there. That will be equal to BP over PC, because those two triangles have got the same height, Therefore, that h will cancel out with the other h, this h here, and that half will go out. And then we'll be left with BP over PC. Does it make sense, guys? So that we can proceed to the next part.
Yes, sir, makes sense.
Oh, okay. Thank you. Now let's go to the other triangle. Now the other one, they are saying ABP. Let me highlight ABP. Or again, it's ABP is this one. And then we are having ABC. Or ABC is the whole triangle. Okay. And then when we look at these two triangles, the red and the blue triangles, still they've got the same height, perpendicular height, h. So now, since they have that a perpendicular height, then we can go for the formula height times base times half. Okay, the numerator ABP will be half times base BP for that triangle times h as the height over the denominator ABC is the whole triangle, the half times the base of the triangle, which is BC, times the height, the same height h. Now, this h will go out with the other one, this half will go out with the other one. We will be left with BP over BC. Does this one also make sense to you guys? My friends are now quiet. Does it make sense to you guys?
Yes, sir.
Okay, thank you. Same applies with the last one, triangle of ACP, ABC. Those are your bases. The numerator will have the base PC, the denominator will be having the base BC. Same height, perpendicular height H, and that half. Those half will cancel out each other. The H will cancel out each other. Therefore, we'll be left with the PC over BC. Now we've got this rule here that the ratio of areas is the ratio of the bases only if we have got the same perpendicular height on those two triangles that we are talking about. Does this part make sense to you guys?
Yes, sir.
Because now is we have triangle ABC and triangle ACP. If those triangles ABP and ACP have same perpendicular height, the ratio of those areas will be the ratio of their bases. Same applies with this one, triangle ABP and triangle ABC. If those two triangles have got the same height and that height is perpendicular to their bases, then the ratio of the areas will be the ratio of the bases. Does it make sense, guys?
Yes, sir.
Okay,
Yes, sir.
thank you. Okay, thank you. Then we are done with type 1. Let's go to type 2. Type 2, common angle parallel lines. Oh, they need to be parallel lines, I think, to this one. Now let's see what we can cook. Oh, the area rule there. Now they are say, oh, we are given this triangle ABC, which is the bigger triangle here. We are also given the smaller triangle. Let me make it blue. This triangle. Oh, these two triangles, they've got that common angle A there. They've got common angle there. They share that angle. Okay, now let's see what we can learn here. They are saying the ratio area of APB. Where is APB? I'm sorry, APQ. APQ is the blue triangle, and then ABC is the red triangle. Now, for those triangles, anyone, guys, who can tell us how we can calculate the area of triangle? Let me do this. Is there any one of you guys who can tell us how to calculate the area of triangle APQ, given that this angle is theta? Is there anyone, guys, who can tell us how to calculate the area of this greener triangle, given that the angle A there is angle theta?
Isn't it half base times height?
Okay. Now you are saying, okay, the area is going to be half times base. I love the try, but now let's see. Hey, what is the base of this triangle?
The small one.
Yes, the small one, the green one that I highlighted there.
It's PQ.
Okay, you are saying it's PQ. I want you to see something. It's PQ. And then what is the height?
It's AP.
Okay, you are saying it's AP. I love hearing this. Okay, is AP perpendicular to PQ?
Oh, okay. I see. No.
Yeah. Therefore, now you cannot go to for this formula. You will be wrong because this formula, that height h there, needs to be perpendicular to that base there. Does it make sense?
Okay. Yes, I see.
Yes. Thank you for noticing that. So now, are you having some idea of how we can calculate the area of this triangle APQ? Oh, my friend is now quiet. But guys, since now we noticed that we cannot go for the formula area is equal to half times base times height, because there is no some height that is perpendicular to the base here. So what you can do if you are given that angle A there is theta, you can go for area rule. Say, okay, my area, this part is going to be half times, okay, we have these two sides, they meet there at that angle A. So, okay, I'm going to take AP times the other side, AQ. Then I times by sine angle theta there at A. Does it make sense to everyone, guys? Using area rule.
Yes, sir, makes sense.
Are you guys sure?
Yes.
Okay, thank you, guys. Now I'm asking you again, how can we calculate the area of a triangle ABC? This one here. Yeah, this one.
So what did he say?
I'm asking you guys, like, which formula can we go for to calculate the area of triangle? Oh, my information is missing. And given that this angle is A, I want you guys to tell me for the formula that we can go for to calculate the area of triangle ABC, given the angle A is maybe beta there. ABC, triangle ABC, the area of it, given the angle A is angle beta. Anyone,
So
guys, who
it's
can
area
give me the
rule.
graph? Sorry?
Area rule.
Okay, yeah, you can tell me, you can just shout out how you can put that area rule. I agree 100% correct. Area rule is applicable to this information. So now how can we apply that area rule? You can tell me is this times this, this times this. Then I will write that and confirm whether that is correct or wrong. And if it's wrong, we do some corrections. If you are right, then keep it up. Yeah, you can just share how you're thinking, what's on your mind.
Me,
I'm
sir.
ready to hear. Oh, anyone. But you can also give it a try. I'd love to hear you try. My friends are quite stray.
It's yeah.
Yeah, go ahead. Give it a try.
So you say the angle there, it's what? It's A.
It's bigger. I mean, it's A, it
It,
can be anything. Okay, let's just say you're given that angle there. Let's just that angle. See that angle A there. Yeah, angle A that you can represent by that. Yes, angle A.
it's half
Okay,
A.
you are saying area is going
Yeah,
to be half. Yes.
AP times
Okay.
AP.
You are saying AP.
Yes.
Oh, okay.
Yeah. Times AQ.
You are saying AQ. Okay.
Sine that angle.
Times sine which angle?
That angle.
Which angle?
Angle A.
Okay, angle A. Okay, angle A. Oh, okay. Oh, this part is correct. Let me do this. This part here is correct. And then this one is wrong. Do you know why?
No.
Oh, can anyone maybe in the group tell us why is she wrong?
Eh.
Can you see that? Okay, firstly, you look at the triangle that you are required to calculate the area of. Triangle ABC. ABC. And then now you work out your area. And then when I take that triangle ABC, it's like this. It's like this. This is our triangle. A, B, C. So I'm asking you this question. Where is P here? Where is Q here? In order for you to
Oh.
calculate the area of ABC. Can you
So
see
you're
me
gonna
say?
say yes. Say so.
Yes.
So you're going to say it's A.
Sorry?
You're gonna say from yeah, that thing. You're gonna say AB times AC.
Now it's correct. And now it's
Okay.
correct. 100% correct now. Yes. Yes. I now agree. Does it make sense to everyone, guys? Because hey, my friends are now quiet. It seems like we are a little bit lost. Do you guys understand? Are these people still here in the room? Let me just check the participant. Oh, we've got a lot of participants here. We have Bongani, we've got Kim, we've got Murumo, we've got Tabile. Are you guys still there? Can you all hear me?
Yes, our
Yes, sir.
convoy.
Yes, sir.
Okay. Oh, okay. Thank you, guys. Thank you. I just wanted to check up on that. So, did you guys understand this part here? Because it's very, very important. You guys need to understand this part in order for you guys to be able to answer those questions on areas. Did you guys understand this part?
Yes, sir. Yes, I understand.
Are you sure?
Very, very sure, sir.
Oh, okay, good. Let me say, oh, you all guys understood. Oh, this time is flying. Quarter to 9 already. Yeah. Now we have got the ratio there. This one here. I want us to look at this part, guys. That part there. Okay. Now the ratio of the area of triangle APQ, which is this triangle over ABC, the bigger triangle, the greener triangle over the blue triangle. So that green triangle, we said it have got the angle there, and then the greener one also. So they've got the common angle there, because these triangles, they've got no perpendicular height. Therefore, it will be a must for us to go for the area rule. Now let's see what they did here. Okay, they said the area of APQ, using the area rule, APQ is the greener triangle, it's half times, yes, that side, AP times this side, AQ, times sine angle that you are having there. Okay, now let's go to the denominator, ABC. We've got half times the whole side times this other side times sine of the angle where those sides that we talked about meet. Then we are having this now. That half is going to cancel out with that other half. And sine A over sine A is 1, therefore they can just cancel out. Now we will be left with AP times AQ all over AB times AC. Does this part make sense to you guys?
No, sir. May you please repeat?
Okay, okay. Let me do this. Let me do this. Do you agree that area of triangle APQ is equal to this R? Why is it to like that? I don't want that size. And then I want, yeah, that is better. Do you agree to that numerator there?
Yes, sir.
Okay. Do you also agree to that denominator? This one.
Yes, sir. I do agree.
Okay. Then now when we check on to that fraction, on the numerator we have half, on the denominator we have half. Half divided by half is just 1. Then you're going to be left with 1. You are allowed mathematically to do this, mathematically. Are you following now this part?
Yes, sir. I'm following.
Okay, we have sine A divided by sine A is still 1. You are also allowed to do this. Are you agreeing to that? Where are you now?
Yes, sir, I agree, I agree. I
Okay.
understand.
Yes. So now half divided by half. I say to you is 1, so it will be 1 times this thing. This side again, we will be having this one here. So 1 times whatever you're having is still that thing. That thing times 1 is still that thing. 1 times A is A. A times 1 is A. So even if we didn't write those ones there, it's fine. They don't ruin anything. Therefore, we will be left with this part here only. Does it make sense to you now?
Yes, sir, makes sense. I
Okay, okay.
understand.
Are you sure?
100%.
Okay, I'm glad to hear that. Now, we are going back to proportionality theorem. Are you now guys agreeing to me when I say now? Let's come to this triangle. When I say AP, AP over PB is equal to AQ over QC. Are you guys agreeing on this statement?
Yes, sir.
Are you sure? Are you
Yes,
guys
yes.
sure? Okay, fine. Now let me do this. Actually, let me write this maybe here. Let's say maybe I'm having AP over PB is equal to, oh, not PB, AB. AB is equal to AQ over QC. Now let's say let AP over AB be equal to maybe let's say X over Y. Meaning if AP over AB is X over Y, then also AQ over QC will be X over Y. Do you guys agree to that?
Yes.
Yes, sir, I
No.
agree.
Okay. If you guys agree to that, now let's come to this part. Okay. This is what you said you agree. Okay. This part, you said you guys agree because we say that ratio is equal to X over Y. If that is the case, now to this part here, this one here, we can just have AP over AB as X over Y times AQ over AC as X over Y as well. That will result as X squared over Y squared. Then that can give us some confidence to conclude that the area of that will be AP over B over AB squared or AQ over AC squared because the ratios are equal. Does it make sense, guys?
Yes, sir.
Yes, sir.
Oh, does it make sense to everyone?
Yes, sir.
Okay, thank you. Then let's go to that other condition. This other condition here. The triangles between parallel lines. Oh, yes. Now they are saying here the triangles with the same base. Oh, this is a very, very important part. We are going to need this information. With the same base between parallel lines. Between parallel lines have equal areas. You guys need to know that. Therefore, now when we comes to this diagram, we have triangle ABC. ABC is this one. This one. We also have triangle DCB, which is this one. Those triangles have got the same base BC here, and they've got the same perpendicular height because they are between parallel lines. Does it make sense, guys, that part to you?
Yes, sir, the cut makes sense.
Oh, okay. Because why will we say they have same areas? For triangle ABC, the area for that will be half, what is the base, is BC times height. Then also for triangle DBC will be half, what is the base there, is BC times height. That is why we say the triangle of the same base between parallel lines have got the same area. Does it make sense, guys?
Yes, it makes sense.
Oh, okay. I think that is the same with this triangle PQR. If you are given that QR is equal to BC, and then the height is still the same because the triangles are between the parallel lines. And that's what you guys need to know. Then now let's go see if we can use this 4 minutes to do some analysis on some problems and see if we can do some. Now let me erase this now. We are all going to analyze this. Why is my eraser like this? But okay, it's fine. So guys, we are having exercise 4 here. They're saying the sketch alongside AF is parallel to DE, and then we're also given the ratio AD is to DC is 2:5, and BF is to FC is equal to 2:3. And then now determine the area of the triangle ABF over triangle ACF. ABF is ABF. ABF. Oh, no, not there. Not there. ABF is this one. Okay. And then ACF is this one. Okay. So anyone, guys, of you can tell us how we can do this question? And you guys need to understand this question because they are so examinable. Anyone, guys? Wow, my friends are now quiet, but let me give you some hint. This
So
is the
question what again, sorry?
sorry.
The question being what's the question?
Oh, this is the
The
question.
question that was-
Can you see this? This is the question. Can you see it?
Oh, okay. Yes, I
Oh,
can.
yes, that is the question. So I just wanted to ask if you guys have got some idea of how we can calculate that.
Okay, I think it's gonna be a struggle if you don't have an angle.
Sorry. Oh, we don't have the angle, right?
Yes.
Okay, yes. Therefore, area rule doesn't apply here.
Yes, sir.
Oh, yes, I agree. I agree. So, what do you think if that's the case?
We'll have to use we will have to times the proportions to get the ratio.
Two times the proportions, or what proportions, maybe?
We'll have to times AD over DS. Am I looking at the sheets?
DC. Oh,
I
that
can't
is
see
C.
the other.
You
Yeah, we'll have
mean?
to do.
Oh, this is C, my friend. You mean that?
Yeah, yes.
Oh, it's C here. It's C here, my friend.
Oh, sorry, I couldn't see properly.
Oh no, it's fine. It's fine.
So we'll have to say AD over DC times I can't get the other side properly.
Okay, so should I continue writing, or
Yes,
should
can you
I
please
give it?
continue for me?
Sorry.
Can you please continue for me, sir?
Oh, okay.
I'm kind of stuck.
To continue for you, let me just continue from that point where you said you don't have the common angle, right?
Yes, sir.
Between the triangles, the greener one and the blue. So that tells you that area rule doesn't apply, because that one that you wanted to do of maybe multiplying the proportion, that comes from area rule. So don't go for that one if you don't have a common angle between the two triangles. You get it?
Okay, sir. Yes, sir.
Okay.
Uh,
So for this one, like when you look at these triangles,
Yeah.
what is common? Sorry? Oh, yes.
What does it mean to times the what? Yeah, that thing.
The proportion.
What he said, but at the first, he said that times the what? We're gonna times what?
He
What
said
are
we're
we
gonna times
timing?
the proportions.
What does it mean?
Oh man, let me go back to this. Let's say now we have this triangle A, B, C, D, E. Now to you, I'm saying A, B, or not B, AD over DB. This is a proportion, okay?
Oh, okay. Yeah, I
Yes.
get it now.
So this, and now doing this over AC is you timesing the proportion. Do you get it?
Okay. Yes, I do. Thank you.
Oh, okay. Thank you, ma'am. I think now it's 2 minutes past 9 on the clock. Do you guys mind if I just finish explaining only number one, then we can continue with the rest next week?
Yes, sir. You can
Yes.
finish off number 1.
Okay, I appreciate it. Thank you, guys. Thank you for giving me that chance. So, did you guys understand why now area rule is not applicable in this scenario?
Yes.
Yes, because there is no common area. If maybe we had something like this, for this triangle and this triangle, now the common angle is that one. Therefore, you can use the area rule. But now our case here is different. We have something like this. We have something like this. Okay. Then we've got that common point there, of which we can construct a perpendicular height to both bases. Our bases, we've got this is the base for the red triangle. This is the base for the blue triangle. Now let's construct the perpendicular height that is going to be perpendicular to both bases. It's going to be here. It's perpendicular to this one. Is also perpendicular to this other one, because it's just a straight line. Does this part make sense? Therefore, our height h will be this one. Do you guys get this part? I've just demonstrated here.
Yes.
Okay, if you guys understand this, let me just shift this triangle maybe to that part up there. It's like this, or like this. Then I constructed perpendicular height to the basis. Now the numerator is this red triangle, which is ABF. Let me just indicate that this is A, B, F, and C there. So the area of triangle ABF, do you guys agree when I say that it's going to be half times base of that triangle is BF times the height that is perpendicular to that triangle is H? Do you guys agree to this?
Yes, I agree.
Yes.
Okay, thank you. Now let's come to this. Then now ACF, which is the blue one there, ACF is going to be half times the base there is FC. FC times the perpendicular height H. Therefore, okay, we have half, this cancel out. We have HH, this cancel out. We are going to be left with BF all over FC. Do you guys understand this part?
Yes, sir.
Okay, thank you. Now, did you all guys understand how we played around these ratios here? Oh man, what am I doing? I'm sorry. I'm sorry, guys, for that. Exercise 4. Then, okay, this is Euclidean geometry here. Oh, we were somewhere here. Okay. Okay, we are here. So I was asking if you guys understood how I played around on getting these ratios here. These ones here. These ones. Did you guys get that part?
Yes.
I played around. Yes, I played around proportionality theorem. Now, when you managed to get to this point, what is BC? What is BC? What is BF? BF from our diagram is 2A. The substitute is there. What is FC? There it is 3A. Okay, A cancel out with A. Therefore, our ratio of the areas is 2/3. Then you are done just like this. Does it make sense to you guys now?
Yes, I can understand.
Yes, sir.
Are you guys sure?
Yes.
Yes.
But it seems like we have to work around these problems a lot. But we will even on our next lesson next week, because I thought with this lesson we will be starting with similarity, but it's fine, guys. What matters the most is that you guys have to understand. So is there any question, guys, regarding tonight's lesson? Or are you guys okay?
I'm okay, sir.
Okay, guys.
Can we just say for the next lesson, can we do more of these odd shapes and say scenarios for the area problem?
Oh, you want us to focus more on this area's problem? The
Yeah,
complicated.
especially with the weird shapes or the weird triangle arrangements.
Oh, no, it's fine, Okay, no, it's fine, no problems. So you guys can just go to that channel. There's still that question I posted, number 1, 2, 3. You can just play around that number 1 and see if you'll get that 2 or 3 to be confident with that. And then you can also do number 2, and then we will confirm the answers next week. You can also give number 3 a chance. Then we will do the correction next week before we can continue. Actually, we can do these problems here as many as we can before we can start with similarity. Then if there is no question that you wanted to ask, guys, I think let's end here for tonight. I will see you again, guys, next week. Have a good night of the Sunday.
Bye, sir.
Good night. Bye.
Oh, thank you, guys. I appreciate it. I will see you again next week.